All right, good morning. Can you all hear me? Good, all right. I hope you all had a good time yesterday, but that you are still able to stay awake for today's sessions. My name is Thomas Hansen, for those of you who don't know me. And today I'm going to talk about how we at ProMark, where I'm the DevOps manager, how we build and deploy our OpenEdge PASOE based application called ProMark. How we build and deploy that onto Kubernetes using GitOps and using ArgoCD in particular. So a lot of stuff to go through, and hopefully you'll find it interesting. Very briefly about ProMark. I'm not going to go into a lot of details about that, but it's ProMark is the biggest ISV in Scandinavia, and with ambitions to grow into the European region as well through a recent acquisition by an equity fund. If we go to the ProMark's relationship with Progress, an ISV Titanium partner, been a partner since 1995. I've actually worked with ProMark since 1995. So when I initially started working for, at that time we had a Progress office in Copenhagen, and I was doing tech support and consulting for them. And ProMark was actually the first customer that I implemented Roundtable with, which is actually still being used. So that was a while back, a while ago. Key Progress technologies we're using: Progress OpenEdge and some Telerik for various parts of the both old and new front ends and reporting. And there's some slides with logos of different companies around, mostly the Scandinavian and UK countries that are being used. So what are we going to talk about? We're going to talk about the stack that we have ProMark built on. It's one of the things that we are focusing on is that we have a single code base for all customers. So all the images, everything that we build is in. We're not doing any customizations. So there is a pretty big effort from Mitch and his team to manage feature requests. So customers, if they need something specific for their business, then that gets included as feature requests that then go into the core product, but we don't have custom deployments, and that makes this whole process and the stuff we're going to be talking about quite a lot easier. We do have support for handling customizations if we need to, but that's not really it's one of our key sort of paradigms, is that we have a single code base for everything. We've just recently upgraded to OpenEdge 12.8. We're waiting for that for a long time, and waiting for a few things there. But for those of you who heard my presentation together with Mircea and Ruben yesterday, we've been using 12.8 for a number of things, testing performance and other stuff there that's come out of that. On the database side, it's an OpenEdge, so that's what we're deploying as well and what we're talking about today, but we also have some Microsoft SQL databases for BI, for data warehouse. Our API layer is based on PASOE, so we're building and building images and creating containers, or pods as they're called in Kubernetes, with PASOE, everything built in. And as I mentioned, all of the code, schema changes, base system data, system text, and so on, all that is managed in Roundtable. And from Roundtable, we have a tool that we've built over the years together with Roundtable and together with other teams that I've worked on. It's called Roundtable Automation, that we use to actually get things from Roundtable into Git. One of the key points of what we're going to be talking about here is that things are in Git, because then we can pick up code, we can build it, we can deploy stuff, but we can also manage our deployment manifests and the way in which we deploy stuff. For our front-end code, everything is in Git, so traditional Git code management. So our Kubernetes deployment model, we have an individual deployment for each customer, a full stack. We are working on that, and we did a presentation yesterday that explained how we're going to be implementing horizontal scaling on that. We do all of our deployments and updates to deployments through a GitOps approach using ArgoCD. Our application stack is completely containerized, with the little twist that we are running databases as standalone databases on Linux, but we can actually run them in containers. We do have the deployment, and the demo that I'm going to show you that's hopefully going to work does actually spawn a full environment with container-based databases. It works, you can use it, but for support reasons, Progress prefers that we run things in a traditional way on a Linux host, so that's what we're doing at the moment. Our application stack consists of a couple of web portals. We have a structure of some batch processes we call delegators, and executors, which are PASOE instances. So we have a mix of those, and then we have the databases on Linux. And that, but a sort of a high-level overview of our architecture looks something like this. If I just jump over to the next slide here, the red boxes here, they indicate what we actually deploy for a customer. So when we spin up an instance, when I do that a little later, that's really what we are spinning up is our portals, our delegators, our PASOE endpoints. These three down here are the ProMark REST, job executor, and data exchange executor are all PASOE instances that get deployed as separate containers. So that's all part of a big puzzle that we need to put together and automatically deploy. And that's where doing this in Kubernetes with Helm charts and then having it automated with something like ArgoCD makes it nice and easy. We have the databases on Linux database hosts, and then we have some services we've moved out that are running as sort of supporting shared services for each of the instances that we deploy, or the customer environments. And we're working on farming out more and more of each of the deployments into that kind of structure. Right, so building our images and how this works, I'm going to go through and just go through the overall CI flow that we have here. To start with, we're managing our code in Roundtable. So we have Roundtable workspaces. How many of you are familiar with Roundtable and maybe even still using it? How many of you are still using Roundtable? Okay, it's unfortunately not a growing community. It's going the other way, but we've been using it for a long time, but one of the things that we were challenged with in really going into and using a lot of the modern tools that are out there, especially for this kind of thing, was that things have to be in Git. So we have this middle layer here called Roundtable Automation, which basically picks up when we commit code in Roundtable and pushes it to an equivalent. Basically, it's a carbon copy of the code that gets pushed into Bitbucket. So for each workspace that we have in Roundtable, we actually automatically, whenever we have a Jenkins CI flow that handles a lot of builds on the Windows side, and that triggers commits into Roundtable that then commits stuff into Bitbucket. And from there, we can then pick up and do a lot of other fancy stuff. So one of those things is that we have these in Jenkins. We have Jenkins is also deployed on Kubernetes. We have what's called a multi-branch pipeline. The multi-branch pipeline basically picks up whenever anything gets committed to. We have a list of specific branches or filters on branches that we're looking for. So, for example, when we push to the RTB devel repo, then a build picks up in Jenkins. There is a Jenkins file included in our code base. So that's actually maintained as part of the code. Again, that is then completely under version control. And that Jenkins file, that's the build instructions for the Jenkins pipeline. That will then based on the branch, based on the version that we're currently building of ProMark and some other things, it will create automatically create images of all of the. If we go back to, if you remember the slide I had with the architectural overview, we've got several images that get built from the same code base. So for each of the PASOE instances, we're creating our code, creating procedure libraries, and then from that creating specific images for each of our executors, for each of our delegators, and at the same. So that happens at the same for the backend part. We have similar pipelines that run for the front end. So for each of the portals, we have which are based on various versions of Angular. Is that correct? Yeah. That get built into images that have an Nginx web server. So we've got these multi-branch pipelines here. We're just focusing on what happens on the back end part, but it's the same thing that happens on the front end part. This then gets pushed to the container registry. Oops. The Azure Container Registry, and here we tag images based on, so the Jenkins file that I mentioned we have in the code, that works out the image, the version of the application that we're building. It also checks the branch that we're building from, and from that automatically generates tags on the images and pushes that to the Azure Container Registry. Yeah, and as I mentioned, the front-end images are also built automatically. So I'm just going to jump in and quickly. Yes. Yes.
Is there a reason to stay on Roundtable instead of just using Git also for the backend stuff?
Not really, but we have some tools that are built in and that are making use of things in Roundtable. But it is actually a project we have that to move everything to Git and get rid of that piece. But we have a lot of things on our plate at the moment, and it's one of those things that's on the to-do list right now. That part works because we also have a fairly big educational thing in getting all of our developers trained up in. Most of them are used to doing it already because they're working on other projects and other parts of the system, so it's not that big a leap. But the switch from Roundtable that is closely integrated with OpenEdge to a pure Git environment is a paradigm shift that we need. We know we're going to make fairly soon, but we just haven't done it yet. Yeah, so. Any other questions? Okay, so I just want to jump over and we'll see. I know that people have said that it may be a little difficult to see some of these things. So let me know if it's too small. So I'm in our Jenkins environment, which is also running as part of our Kubernetes infrastructure. I'll give you a brief overview of what that looks like a little later. But whenever we get commits, I can see right now that in our development environment, we had about an hour ago, we had a commit that came in. So whilst we're here at the conference, we do have people that are committing code, and that's automatically being picked up. And the build that we've then gone through here has resulted in an image for the devel branch, which has our version number 581. It's build number 761 of the devel branch here. So this image tag here, we can go and check to see that we actually have images that have been created in the Azure Container Registry. So this is a fairly, I think this, if we go back to this one here, the pipeline itself takes about 25 minutes to run to do a full build on the back end. And this is multiple containers that we are creating. That then goes into the Azure Container Registry. And let's see if I can find the build number that we were talking about. It was 761 devel. Was it not? What we do is, in addition to the tag that I have here, in fact, if I go and look at the, I'm just going to scroll down to the end of the. We can see there's a lot of different underlying pipelines that get created for each of our different components here. But what we do in addition to the very specific tag that I had here, we also always build in the case of the develop environment here, we also build a devel-latest. We have internal discussions, though. For those of you who are working with containers, you might have the same discussions about whether or not latest is a good idea or not. Some people think it is, and some people are very have very strong opinions about that being a bad idea. So what we don't work with latest. We do it if we're testing stuff, and if we're testing images and builds sort of. But we don't use them in production. In production, we always have very specific tags that we're using, so that we know exactly which build version of the application that we're running on. Any of you who are in favor of using latest? It's if you're picking up public images, in most cases you're going to be using, unless you go and specifically change it to a specific version of an image, then you're going to be by default be pulling the latest image. Right, so these images here are now ready for us to start using, and we then need to start putting them together into the deployment structure that that I was talking about before. So this is again the prerequisite is that things go into Git. We have this multi-branch pipelines that pick up. If I go over and have a look in. We also have, for example, for our front-end portal, we also have a pipeline that triggers for. Right now we are on the is it the develop branch? The develop branch here. Someone committed to the front end also, and you'll see that each of these, you can see the tag that we get here is different, because it's different repositories and different number of builds that we get. So that's part of what we need to keep track of. Is for in the case of our front end, we have two different images that we're using. We have for our portal and what we call our admin portal, and they would be two different builds, two different image tags. And then for our backend, the image tag for all of the different pieces that I showed before, they're going to be tagged the same. So a lot of our images are actually going to have the same image tag, but that's part of what we need to know and manage. Right. So that's just a quick run through of that part. Let's get into the more interesting bits. Come on. Okay, so when we deploy our application, we do that through Helm charts. And the way we're doing it is a deployment is manually triggered to start with. So we go through, and I'm going to show you how we do that in a second. And when we create we have a pipeline that runs in Azure DevOps. So we're using Jenkins for some things, and then we're using Azure DevOps for other things. And it's really because there are some things we're using Azure for pretty much everything in the cloud, and there are some dependencies and some things that Azure DevOps that it just works better from that. The user experience, in my personal opinion, for building stuff and creating pipelines and so on is much better in Jenkins than it is in Azure DevOps. I'm not a huge fan of their UI and the way things are laid out, but it works, and there's a lot of people that are using it. It looks like it's been put together from various different tools over time. So we're using these two different build technologies. We are looking at whether we could merge all that into one at some stage. But basically what happens is our pipelines, they create a manifest file. We're going to have a look at what that looks like. But it's basically, how many of you are familiar with Kubernetes deployments and Helm charts? So a small handful of you. Okay, what about Docker Compose? Okay, so more of you are familiar with Docker Compose. So Helm charts are just a much more complicated version of Docker Compose recipes or Docker Compose files. Helm charts they're both YAML files, and they basically contain the recipe for the deployment of your application. So we have a Helm chart for the ProMark application, and that we manage that in Git as well. So we actually have different branches, different version numbers, and so on for the Helm charts as well. So we can handle things. We can make application version specific changes to our Helm charts and make sure that we're always deploying. If we're going to be deploying an older stack with older images, that we don't break things by having made changes to our Helm charts that then get that may have breaking changes. So what happens is we have some code that I think it's called InfraGen. There's a tool, there's a plugin that we're using that actually generates a manifest file that is for those of you who have worked with Kubernetes, when you have a Helm chart, you also have what's called a values file. And the values file contains the Helm chart contains the recipe for what it is how you're going to deploy your containers, your pods, your services, your network, how the whole thing hangs together. The values file that you use is the one that gives you the specific details about what are you calling your containers, which images and which versions are you going to be using, and a number of other things. So these manifest files that we're creating are really just YAML files with the values that are for that specific deployment. They get created and they get checked into Git. So we have, and then we have ArgoCD, which is a continuous deployment tool that's used quite frequently in the Kubernetes space, that basically monitors a Git repo for changes. And whenever there's, for example, if we deploy a new environment, if there's a new manifest, it will pick that up, it'll parse that, and if there aren't any mistakes in it, it will then go ahead and actually deploy the contents or the settings stored within that manifest file. It'll deploy that into the Kubernetes cluster that we specify. So we have it all set up so that the different we have a completely separate development environment, test environment, and production environment, and that translates into completely separate clusters that we have on Azure. We've separated them all the way out to have them in different subscriptions on Azure also. So we have completely separated environments where we have a full Kubernetes cluster for development, for test, and production. And these manifest files then get created in the right branch. They get picked up by ArgoCD. If it's in the test environment that I deploy something, then it'll be ArgoCD running in Kubernetes. It's part of our infrastructure that will then pick up and deploy those files. Once it's deployed and everything's up and running, if I need to change something, I can't go into my running containers or pods and change something, because most of what's inside them is completely locked down. We do have some external storage and stuff that gets mapped in where you have files that you can modify, but config files like changes to the OpenEdge properties on PASOE or PF files or something like that, all of that is completely locked down, and that's completely managed either by default template files that we have within the Helm chart, or it's handled in the manifest itself. So if we have places where we need to override things like logging levels or what to include in logs, or IP addresses we want to set as whitelisted IPs on our SFTP service, those kinds of things, that's all in the manifest file. So if we need to change something on a deployment, we need to basically create a commit in Git with the changes. We check out and make changes to the manifest file, apply those changes, make a pull request. When that gets approved and gets merged in, ArgoCD acts in just as it does with a new manifest file. It parses it, sees it's changed, and it applies those changes automatically. And that process means that we can very, very quickly and easily update our stacks. On the traditional Windows environment, there's a whole manual install process that takes several hours to go through if we're installing on a machine. we can update our container-based instances in a matter of minutes. The longest time it takes is waiting for ArgoCD to pick up the fact that something's changed and then push it. So that's very useful.
Why wouldn't you use Git to push to Argo?
Sorry?
Can't you use some event hooks to push?
To Argo? We could do, and we can go in and trigger it to pick up things a bit quicker, but it's running on a schedule. It only takes a few minutes for it to pick up. But the nice thing is that it's just monitoring the Git repo. You could via CLI trigger it to do something specific. We're just relying on the fact that it just keeps an eye on things and does it for us. Okay, so basically what we're doing is we run a pipeline that picks up, reads the manifest, goes to the registry, checks to see that we have the images that we've specified in there, and then deploys into the right cluster. If we make changes, we do it in ArgoCD, and so that's a repetitive process that we have there. We do also have the possibility of doing automated updates. So we've actually put something in place so that instead of manually having, whenever we have builds, let's say we have a stack that's running on our current development builds, then we monitor the fact that new images have been created. We've got commits that have been made, new images have been created, and we then have an Azure DevOps pipeline, and I'm going to show you a demo of that at the end of this session, that actually automatically works out what the correct image is to get a particular stack updated and then gets it updated. So we do, for some of our stacks, from the time we build an image to it automatically being updated is less than an hour. So we will actually have in a production style Kubernetes environment, we will have stuff that automatically gets updated. Okay, so let's see if we can get this to work. So I'm going to go over to Azure DevOps here. Any of you using Azure DevOps for your a small handful? How many of you using GitHub instead? Bitbucket? Something else? GitLab? GitLab? You're not allowed to use GitLab anymore. Okay. Okay, so this is in Azure DevOps. We have a number of different things. We have. Oops, what did I do there? We have pipelines. We have repos. So if I go in, let me jump in and just show you quickly. So we have a structure on our Kubernetes setup. We have everything is managed through infrastructure as code. And our infrastructure itself is also managed by ArgoCD and deployments. So for every cluster that we set up, or for every environment, development, test, production, we have what's called a management cluster. And that cluster contains Prometheus, ArgoCD, Jenkins, and a few other core components that are part of the main infrastructure. And then we have a parallel application cluster, which the management cluster manages, and that's where ArgoCD deploys stuff into. So, and within that, to manage that, we have what we call app of apps. So app of apps with ProMark, if I go to the test environment, for example, and have a look here, then I have a whole bunch of YAML files here. I don't know if you guys can see that. I'll zoom in a bit. Is that better? So if I take for example, we have our QA 581. 581 is our latest version of ProMark. This manifest file here contains the details of our QA environment that actually gets regularly updated. So one of the key things that we have in this, if we just run through that quickly, is we have we point to a specific branch of our Helm charts. So this is where we specify which version of the Helm charts are we using. So even though we are right now on QA on version 581, we're actually in the branch that we're using is still called test 581. I have some discussions with people on my team about how quickly we should be creating the next branch for the next version, but our tech team lead on this part, who owns the change management part, insists that we do this as late as possible in the release flow. So we won't be creating the 581 branch until a little later in our flow. Then we've got all these different values that are being set up for the environment to be spawned. The customer name, we use this in several places for, among other things, the URL that we can access the application when it's up and running. We can set some domains. There's various different services that we're using, but really the interesting part is when we get down to here, we have for each of the different services, these are the different components that I had in the slide before with the architectural overview. Each of these, for our admin portal, we have an image. What's the image that we're going to be using, and what's the image version that we're going to be using? This is the information that we're maintaining as part of the manifest. And so a lot of things that are image specific, but there can also be other things that are specific to each of these different pods that we are deploying. So depends on what they are. The default one, if I take this one here with ProMark REST, our REST API, we actually have they're not set if they're not the default, or if they're using the default values, but we have a whole bunch of other properties that we can set here for the PASOE pod for things like changing the logging level of the PASOE instance, or changing the number of agents, or the number of sessions per agent, connections per session, and those kinds of things. So we have overrides in there, and so this is a good mix of, you can use the Helm charts as templates, and then you can take information from these manifest files, and you can replace those at deploy time, so that you in that way can make changes. I think if I go in and have a look at one of our production environments, I believe these ones here have a little more. Where are we? That's test. That was this one I wanted. Yeah, you'll see here, for example, on ProMark REST, on our PASOE, on our REST layer, we're setting, here we can increase and adjust the memory that gets allocated to the pod. Part of what we are trying to work out is the optimal sweet spot in terms of memory on our pods, because it's a bit of a balance when you're moving into a containerized environment. You don't want to be, you've got to be careful you don't just give all of your PASOE pods 8 or 16 gigabytes of memory, because then you're going to have a ton of nodes in your cluster that are not really doing anything except consuming a lot of very expensive memory. So when we're running everything in containers, we're using a lot less memory, and we need to balance out the number of agents, the memory, the number of agents and connections, and find out how that fits in. And that can be different from, in this case, from customer to customer, depending on how many users and the activity. So we can go in and adjust some of those things. So you see here we have ABL sessions per agent, the maximum number of agents and connections, and that's something that we can tune in here. So when we deploy that, if I need to change anything, I need to bump up and say I want to increase the memory or reduce the memory, I change it in here. I make a commit, make a pull request. Once that gets approved, gets merged, then ArgoCD picks up and deploys this. Right, so if I was going to spawn a new environment, I do that by running a pipeline. Here I'm just going to take a run of an existing one of the previous runs we had, and I'm just going to change the customer name here to PUG. There's a whole, you'll see all of these different properties or parameters that I have that gets passed into the pipeline. These are part of these get set inside the manifest file. So this is why I set the different the tag for the different images that I'm going to be deploying. So I had someone on my team tell me I should be using some specific tags here. So for this one here, These are not. These are actually our production tags. You'll see they have much shorter. These tags are much shorter because this is actually our release tag. So release 580, and it's actually on what we call hotfix number 5. So if we need to fix something after we've released a version of the product, then we try to keep as few builds as possible here. But that's sometimes we need to hotfix stuff. So I'm just going to go through and set this on each of these different images. I'm going to go with the database version. We actually have, for all of our databases, we have images created with full schema and data, so that we can spawn up a database directly from our container registry. What we've also done is we can actually use the image to create a native Linux database. So basically spawn up a temporary container with the database image, extract the database files and write them to disk. So we're using the container registry as a way of having template databases as well. What I'm going to do with this one here is, instead of spawning a separate Linux database, I'm actually just going to run this in a pod itself. So I'm going to go through, and there's one thing I need to change. There's a lot of different things we can set here, for whether we're enabling single sign-on, Azure tenant IDs for app registrations, time zone. I just need to remember here to change the name of the SFTP service that I'm spawning. When I click run here, this is then going to go through and run a combination of scripts. Let's see what. Come on. Here we go. I don't remember how long this one takes, but you see that we're going to get, it's going to run a number of different things, some Terraform, it's going to use some ArgoCD and something called Infogen, which is the tool we use for injecting manifest files. It's going to run through, so this works out how to create the manifest file, and then it's going to go through and actually make our deployments when it's done here. This one's finished. I'm not sure what's going on here. Okay, what we could do is go over to Argo on our test environment. And just have a look here. Here we have all of our applications. We have an application called ProMark, and within the ProMark application, we have a separate sub-application for each of the environments that we've deployed. So I can see here that right now there's, let's see if it's picked up on the PUG one. Is this running? See, my PUG test environment here is actually being, it's busy deploying that at the moment. So it's going through and doing a lot of stuff that we would otherwise have to do through the CLI with Helm deployments. So I can also go in here and look for, instead of if I go and search for applications here and I search for the PUG application, I can see that it's in the process right now of building my application. So it's deploying a whole bunch of different config maps and services and all of these different components that make up my application. It's not quite finished yet. I can see there's a spinner running on this one. So there's a lot of stuff that gets deployed. It's a lot more complicated than a Docker Compose file, for example, where you just have one file where everything's contained inside it. So the end result of this, when it's finished, I'm not sure how long this takes. It may take 5 or 10 minutes more. Is that in this particular case, I'm going to have a full stack of our application with the database and the pod. Everything will be started up, and I should be able to then access the running application. If I go over and just refresh my repository here, what I should see now, let's see if we can pick that up from test. I have a PUG manifest here. So this is the manifest has been created here, and these are all the details that we put in, the different image tags that were created. So this is what's busy being deployed at the moment.
Do you have a separate cluster for it, or it's just another namespace?
We create a separate namespace for each deployment. So all of these pods get deployed into a separate namespace. So all part of the same cluster. So this is deployed in our test cluster, but it's a separate namespace for each customer. So in this case, there will be a namespace there will be a namespace called PUG that has this deployment. And with some luck, it's not up and running yet. We have some other stuff happening on the pipeline that is spinning up, creating DNS entries and doing a bunch of other things. Yes.
We have it sooner set up, right? But the biggest challenge for us is keeping the database up to date. So we look now at how you deploy mostly the application code.
Yeah.
And you select basically database schema version. So that means you keep your database schema basically as
we keep the schema for the database on our images in sync, so that if we're going to create new databases, then they're always going to be in sync with the latest version of the Arco, or the Arco that gets created as well. We have other pipelines for doing the database updates. So this one here is just for spawning a new environment. For the database updates, we actually have some Jenkins pipelines that are then using. We actually have an image we create that contains all the DF files that we have for the database, so that we have that in the registry as well. So whenever there are changes made where that include schema changes, we update our update image, so that we can always spawn a container that can be used to update a database. So it has all the tooling, the scripts, the DF files that are needed to update the database, both in containers and on Linux. But it's a separate process. So we're not handling database updates are not being handled by the ArgoCD part. We are looking at tying all that together, but that's something we haven't completed yet. Yep, good. Okay, so we get these manifest files, and this is our environment that gets spun up, and for some reason it's not creating the DNS entry, so I can't show you that it's running. I think that's. So I was meant to show you that it was actually running, but that's unfortunately not happening right now. I'll just give it a last go. No, not for. But so what I should be seeing is something like this. So this is the QA environment. Yes. It's a little slow here, but so I'm not sure if I can. Whoops, log in with this one. I don't remember the password for this one. Anyway, I'm not sure. I'm not demoing the application, so that's okay. So hopefully you get the idea that we get a fully functional environment spun up, and if we then, for example, with the database need to update that, now it's running in a container, then we're going to have to that's one of the things we haven't really automated at the moment. How do we get our databases in containers updated? On Linux, it's not a problem because we have the physical files there. It's a little more difficult when things are running. If they're running in containers on a Linux host, that's okay. But when they're running in Kubernetes, then we need to run some processes inside the database pods themselves to do updates, and we can do that also. That's just not something we spend a lot of time on right now because our focus is from production is to be running databases directly on Linux. Sorry?
Can create a new image.
We could deploy a new image, but then we lose the data.
And then we use the new image, and then you don't have to go to Kubernetes itself.
We could do that, but yeah, it again depends on if it's just a test database, it's not a big problem. But okay. Come on. Yeah, so if I was going to make some changes and update the version of my, let's say I had a new build. Oh, sorry. That's because I'm in. Come on. Not sure what's going on here. So if I needed to change something, I get a new image or I need to change some properties, I would have my repo cloned locally somewhere, or I could go in here, I can modify it directly and make changes. So if I wanted to upgrade to, say, hotfix 6 of these different images here, commit that. If I'm doing it properly, I should create a branch first for my change, make my commit, and then have someone review a pull request, and when that gets approved, then it gets picked up by ArgoCD. Yep. So that's one way of doing it. The other way is that we actually have some pipelines that can automatically do updates as well. And let's see. So this is going to be a little interesting to see whether this works. I cheated a bit, or tried to cheat a bit, and let's see if this works now. So one of our colleagues back home is actually in the States at the moment. He volunteered to demo the auto-update feature for us, and it's he's the one who wrote it, and I don't use it very much. He sets it up and maintains it, but he's recorded a video, and I'm not sure if we have sound coming out through the HDMI. So let's just try it out and see. Are you only getting it over there? Okay, all right. Let's see if we can get. I should have checked that before. Yeah. Let's mute Henrik here, and then so basically what Henrik is showing here is, and I don't know if you guys can see this with the resolution, but the way we handle automatic updates is that we have a separate pipeline. We create a pipeline per environment. So we don't have one environment that manages all the updates. So if we have an environment, we spin up environment, Mircea and his team need an environment to work on, and they would like to have it automatically updated. Then we set up, as part of our launch process, we then go in and create a pipeline that's attached to that particular environment. And that pipeline will then also that it runs, I think we can set it on different schedules. So the ones that he's showing here are running every hour. And it goes out to check. What it does is it checks the container registry for changes in images of a specific that fit a specific pattern. So it sets up for each of the environments what is the image pattern that we're keeping an eye on, and then it goes out and checks to see using from Azure DevOps. It's actually using some PowerShell code. Henrik is a very big fan of PowerShell, so he's been trying to convince me that we should actually be installing PowerShell on all of our Linux servers and everybody should move to PowerShell. But that's not going to happen. But anyway, we've got some code that basically scans through and goes out and checks to see are there any images that have changed for this particular environment, and if there are, then the code will automatically check out the basically make a commit in the manifest that we were looking at before, update the image tags, and commit that, and then ArgoCD will pick up and push that. And that works very nicely. It means that we can have environments that are updated on. I think it wouldn't make sense to do it every 5 minutes, but within an hour maybe from code gets committed to gets built to images are available to we can have it up and running in our cluster. If you want it faster than that, you would need to have a local environment where you can actually pull your images. We could probably do it faster than that, but it's got to fit in with the build times as well. Yes?
How seamless is that update? Because if you are you're spinning up a new pod, I guess, because I'm not that familiar with Kubernetes. Mm-hmm. That means you're also tearing an old one down.
Yeah.
Is there some kind of possible problems?
So the way Kubernetes works by default is that when if you replace for example, if we do an update, what Kubernetes does is it actually spins up the new pod first and waits for that to be available. So part of the way we sort of check that a pod is healthy is we're using, for all of our PASOE images or containers, we're using OE ping as either from the REST or the web protocol, and that's the health check that Kubernetes continuously makes to see that the container is healthy. So it waits for the new spawned pods to be registered as healthy based on the health checks that you set in your Helm chart, and then once it's up and running, it'll tear down and get rid of the old pod. So in theory, we can do seamless updates without any problems. It depends on what it is you're doing, and because the PASOE parts are all stateless, users shouldn't be affected. But there is we don't do updates like this on production environments without having cleared that with customers first, because it does. If you do have active transactions that are going on within a PASOE container, then at some stage when the new container shows that it's healthy, anything that's running the other one gets nuked. So we have to be a little careful with that. But in theory, we can do updates without affecting anyone. It's just best when nobody is actively using the system. Yeah, and it depends obviously on what it is people are doing. Right, so let's see. We're almost out of time, so just in sort of quick summary, we're building all of our components from Git. Some of them take a little while to get into Git because we're going through Roundtable first. But Git is really the prerequisite for this, what we call GitOps approach of making deployments. We have a Jenkins file that has the recipe for the image builds in them. It also has a Docker file. So there's a Docker file and a Jenkins file, and those are important to have as part of our repo for things to be built. We have the image tags, the version numbering that we set, so we can always identify the different images we want to use. We store all of these things in the Azure Container Registry, so our registry is really the base for everything that we're going to be deploying it. And we're using Helm charts for deployments, and combine that with the environments that we can create either from a pipeline or the ones that we update in these manifest files, which are essentially our values files. So YAML files with details around the structure of the particular environment that we're working with. So that was what I was going to show you today. It's a very quick run through. There's a lot of stuff happening under the covers that would take much longer to explain, but I hope you get a good idea of how you can actually take an OpenEdge application that is actually quite complex, a lot of different components, a lot of different moving parts, and automate the process of spinning up and maintaining new environments. This approach here has given us it's a huge leap for us in terms of maintaining environments, going from Windows into the containerized environment. It means that, for example, when we do updates, if we have our on-premise Windows-based environments, that's usually something we agree on a service window of 6 to 8 hours with our technicians who are then doing the updates. On an environment like this, we can upgrade an environment in about 15 minutes. Maybe even faster than that. Yeah, I think the thing that will take the longest is actually not switching to the new images and getting those deployed. It's database update processes or data processing that comes with an update or something like that may take a little while to run. And the real big benefit of this is that everything is completely locked down. We can identify exactly which build and which versions of the code that we're running with, so we can make sure that all of our deployments are the same. It does make it a little difficult for debugging sometimes, because you want to go in and tweak a config file somewhere and see what effect that has. It is possible to deploy files into Kubernetes pods so that you can modify them, but by default, I think for security reasons, the Kubernetes project actually decided a few years ago there's a setting when you deploy files through config maps where you can set that it should be, whether they should be read-only or not, but for some reason they decided to ignore that completely, so it doesn't matter whether you put read-only true or false, the files are always read-only. You have to jump through quite a few hoops to get modifiable files inside your pods to work with. You can map them as external storage, or you can use what are called init containers to get those in there. But the nice thing is that you know that this is a system we've built, we know how we've built it, we know what versions of the code we've built it from, and it's not possible to tamper with it. And we can very, very easily streamline the different versions that the system's running on. Yep. Any questions? Yes?
How many people do you need to maintain this system? Is it just you, or?
We are 8 people on my team, and so it depends on what you mean by maintaining it, because we're obviously both designing it and building it and so on. So it really depends on how many customers we are managing. But it's not really the time-consuming part is not applying these updates. It's building the tools and making sure they work. Good. Well, thank you very much. Enjoy the rest of your conference, what's left of it, and thank you. It was very good to see you all again, and hope to see you again next year in Antwerp, or where we decide that we are going to have the conference next year.